So here we have graphing rational functions, and we have a lot of stuff to find for this one. This is one of the ones that takes a minute. The first thing you need to do is you need to factor the top and bottom in their entirety. Now, you should probably take a little more care with this, but I know that the top factors into x minus 3, x plus 2. I've done videos before and you know how to factor. And the bottom factors into x plus 3, x minus 3. Now, if you'll notice, things do simplify. X minus 3's cancel out. So I'm left with x plus 2, divided by x plus 3. So I have a couple things to figure out, and I'm going to start kind of color coding them as we go. So the first thing is if there are any holes. Now, holes come from things that cancel, and something did cancel. I have a hole at x minus 3, or in other words, the solution to that. If I take x minus 3 and set it equal to 0, I have a hole at x equals 3. But I need a coordinate point for this. So what I'm going to do is I'm going to take this 3 and plug it in for x in the most simplified version to see what I get. So I have 3 times 3 plus 2 over 3 plus 3, or in other words, 3 times 5, or 15, over 6, which I'm not going to do the exact decimal representation, but it's kind of icky. So I have a hole at 3, 15 over 6. The next one I'm going to do is vertical asymptote. Now the vertical asymptote is whatever is left in the denominator. So here I have x plus 3 left in the denominator. I'm going to set that equal to 0 and solve. So I have a vertical asymptote at x equals negative 3. Now the next one I have to decide if it is a horizontal asymptote or a slant asymptote. Now if you'll remember, if the degrees are the same top and bottom, then it is a ratio of the leading coefficients. If it is bottom heavy, or if the degree on the bottom is bigger, then it is y equals 0. If the degree on top is bigger, then it is a slant asymptote. Now you'll notice on top the degree is 2, there are 2 x's. On the bottom the degree is 1. So this is top heavy, it has a slant. Now the way that we find the slant asymptote is through synthetic division. Alright? Now, what we're dividing by is always going to be the vertical asymptote, 100% of the time. Vertical asymptote is negative 3, we're dividing by negative 3. Along the top are the coefficients of the numerator. So in this case, we need the FOILed version of the numerator. So this is x squared plus 2x. And remember that we need a third term, right? X squared, x, no x. So I can always add 0. So the coefficients are going to be 1, 2, 0. Now synthetic division, drop the 1, multiply by negative 3, add, multiply, add. Now you'll notice that there's always a remainder. That is a good thing. I don't care about that. So here's my slant asymptote. My slant asymptote is at y equals 1x minus 1. So let's get all of that graphed up here. So I have a vertical asymptote at x equals negative 3. So I have a dotted line through negative 3. I have a slant asymptote at 1x minus 1. So this starts at negative 1, and the slope is up 1 over 1. Starts at negative 1, up 1 over 1, up 1 over 1, yada, yada, yada. Now, for this one, I need to find x-intercepts and y-intercepts. So let's find some colors I haven't used. So for an x-intercept, is found by taking the numerator and setting it equal to 0. So in other words, x plus 2 equal to 0. If I have two things multiplied together that equal 0, each independently equals 0. So I have x equals 0 and x plus 2 equals 0. This one's already done. This one is at negative 2. So I hit my x-axis at 0 and negative 2. For my y-intercepts is found by plugging in 0. So in other words, in this whole thing. So I have 0 times 0 plus 2 over 0 plus 3. which is 0. So in other words, I am hitting the y-axis at 0. All right. Well, this is enough to go off of. If you needed test points, you could certainly choose test points. But I know that the graph has to go through these 2 points, and it has to follow the asymptotes and not cross over them. So the only way to do that is to go along. Now, theoretically, your graphs are not going to touch the asymptotes. And I know that they cannot buddy up, right? You cannot squeeze together asymptotes. So it cannot be going up on this side. It has to be going down, which means this guy has to fit in this little curve.